Yeah, I've been following all your updates, and it's incredible.
Thank you.
I see we got Willy Blue in Sweden here. That's awesome. I'm now back home. How was your guys' day? Not gonna lie, I on my travel home, I smashed my thumb in. And I think I have like internal bleeding in my thumb now, which is great. I don't know why I decided to share that, but yeah. So it's a bit hard to type because I literally can't even feel my thumb. Can I share my screen? Like your toe? Yeah. Yeah, my whole body's broken. Great. My entire body is just falling apart. But yeah, no, literally, like I have like internal bleeding in my thumb right now, so I can't even like use it to type. A bit traumatizing, actually. Um, yeah, yeesh, right? But yeah, wow. So it's I'm not gonna lie, NFT NYC was so fun, but it was probably one of the most exhausting things I've ever done. And yeah, I am definitely happy to be home for a sec. Because of Jimbo, yeah, no, meeting Jimbo in person was so funny. Because Jimbo's one of those guys that like when you're around him, there's just so much energy going on, and like I love it. So we would always like late at night, we would always end up. I don't know how, but every single night when I would go out, I would always end up with Jimbo and Eric. And when you put Jimbo and Eric from party groups together, it's like a nonstop just like fiasco. Like they're just the life of the party, and they're so funny. So yeah, being around them was both extremely awesome because they're so nice, and also just tiring because it was just a lot going on. But yeah, that was great. Last night I actually met Roham, and I don't know if you're all on Twitter at all, but I took a nice picture with Roham, and the gang was all there, and El Dumbo, Luke was there, right? So Andrea was there. Um, so seeing those guys out was awesome, and got to spend a lot of time with Sweet and Willie Blue and BZ, which was one of my favorite parts. It was all around was really great. But yeah, I can't even describe like how tired I am. Seriously. And I like just got home like 5 minutes ago. All right. So I know that the last workshop was a bit rushed, and also it wasn't that great because I was in New York City, and the stream wasn't the best. So what I'm gonna do is I'm gonna spend a little bit of time like reviewing what we did during the last workshop. I also think I uploaded the recording for the previous session to the website. Maybe I haven't yet, but so if you've watched that, then that's awesome. And hopefully this will just be a review for you. But yeah, so let's just dive right into it. So last time we talked a lot about account storage, right? So we were saying, what if we want to store stuff inside our account instead of like inside just the contract itself? So we talked about saving to account storage, loading from account storage, so taking a resource out of storage, and also borrowing from storage, which is when you get a reference to a type in storage. Um, so those are the three things we talked about, and they're going to be really useful today when we talk about NFTs. So this workshop is going to be the beginning of NFTs. I told you at the beginning of this bootcamp that you would walk away with it with your own NFT contract, and so we're actually going to be starting that now. And for the rest of this bootcamp, we're pretty much just going to be working on the NFT contract. So woohoo, yay! All right. Um, so one of the problems, like before we really dive into that, let's go over some of the problems with account storage. Maybe not problems, but just some of the quirks that come along with it. So right now I have a NFT contract. It has a NFT resource inside of it with a simple ID, right? Nothing special. And then it has a function to create the NFT resource and return it back to the caller. And so, yeah, of course, we need this because we can't create resources outside the contract. So we need a way to expose that to the transaction. So inside the transaction, what we were doing was I told you that inside the prepare phase, we could access the signer. So you can rename this whatever you want. I like to rename it signer because it's more clear to me that this is the signer of the transaction, right? So these 5 accounts are like test dummy accounts that we can use to sign transactions and access their account storage. So one of the things that we did was we said, like let's first create our NFT. So let NFT be, hello world that create NFT. And all that's doing is just taking, hello world.create NFT, which is this function returns an NFT resource, and it's moving it into this variable. And so what we can do is we can say, okay, signer.save. We're going to save the NFT to storage by moving it in, and you save it to, slash storage slash whatever we want to call it. So in my case, I'm going to call it my NFT. I don't know why. All right. So now this exists in our storage path. And like we mentioned before, the storage path is where all your data actually lives. So the cool part about this is, we can actually in the execute, let's just log like I'm done so that we know that, the transaction went through. So let's execute, let's send this and it says I'm done, right? So perfect. So we took a resource and we stored it inside our storage here. Now, does anyone have any guesses what's going to happen if I run this exact same transaction again? Is there going to be like a weird problem? And since there's not that many of us, if we don't get responses, then oh, okay, nice. So we have some responses. So Waz says yes, there's going to be an error. Oh, hey Ricardo, what's going on? Hope everything's going awesome with you, Ricardo. You're having a good week and happy Friday. And also thank you so much for doing so much with quests. Amethyst error R2E2 says yes, so you would all be right that this is a this is an error. So yeah, happy Friday. So this is going to be an error, and the reason it's going to be an error is because something already exists at this storage path. So if we were to run it again, it's going to say, wait a minute, error failed. Save the object. It already stores an object. Okay, so we can't do it again. All right, but of course, if we were to run this from a different account, it would work because this account doesn't have anything at that path. So good job, everyone, for noticing that. So this brings up a really interesting problem when we talk about NFTs, and the reason for that is because with NFTs, we're going to end up having a lot of NFTs. We're going to have, like, for example, with goated goats, right? With goated goats, you're going to have, if you bought 10 of them, you don't want to store them all at different storage paths. And the reason for that is because then there would be no way as the developer or as some application to know where your NFTs live. So I'm going to repeat that again, and just to hopefully clarify this problem, like let's say you have some front end, right? You have some website, and the website, when you load the page, wants to display all your NFTs. Or let's say you're in Blockto app and you want to display all your NFTs. Blockto app or whatever website you're on is going to have to look into your account and it's going to have to somehow find all your NFTs. So the problem, if you were to store all your NFTs in a different storage path, is number one, you can name this whatever you want. So there's no way for the the caller, blocked over the website, to know where to look inside your storage, right? There's no way to know. And B, it would have to somehow not only know where you store them, but borrow from every single one of the storage paths. And so there's even no real way to know how many NFTs you have, right? Unless the person told you, but obviously, you don't want the user to do that when they're loading onto your website. So does anyone have any ideas of how we can solve this problem? What is a good way to solve the problem where we want a lot of NFTs, but we want, to tell the client or we want the DApp to know where they live? Is there like a good solution for this? And if you don't know, it's okay because we haven't really gone over this concept yet, but you might be able to take a guess. References, that's close. So yeah, it's actually that's part of it, but it's a little more abstract. So what Amethyst says is correct. Yes. So it's collection. So the answer to this is what we can do is we can make a Willie says, oh yeah, you're close. What we can do is we can make a resource, right, called collection, and then we can put all of our NFTs inside collection and then store the collection resource at one storage path. That way, it's only at one storage path, and we can ask our collection, how many NFTs do you have? give me information about this specific NFT, deposit or withdraw from that collection. And it's all existing at one path. And so what you can do is Go to Goats, right? The creator of Go to Goats can tell the client, as the front end or the Block.to app, can tell the app, okay, look at this storage path for everybody. And everyone will have their collection at that certain path. And then it's really easy to read what NFTs you have at that location. So that's exactly what we're going to do today is we're going to define our own collection. So public resource collection, just like that. And then we're going to make a function called create collection that just returns a collection resource. So pretty similar to what we have below, return create collection. Cool. So what are the two most basic functions we can have inside a collection? Anyone know? Like, what are the two things we absolutely need for a collection in order for it to even like work? And while you're thinking about that, I'm going to make a variable called owned NFTs that stores the NFTs. Deposit and withdraw, right? Yeah, exactly. So yeah, great job. So obviously we need a deposit and withdraw function. And so what I've done right now is I've taken, pub var owned NFTs. So this is, as we've learned before, if you have a dictionary, right, with resources inside of it, you have to put the @ symbol in front. So what we're gonna do is we're gonna map the ID, right, the ID of the NFT to the NFT itself. So if we have an NFT resource with ID 1, we're gonna map 1 to the NFT with that ID. Okay. That way we can say to our collection, hey, give me information about NFT1, and it will return a reference to that NFT. Okay, so we have the NFTs here, and so we need a public function deposit. And what this is going to do is take in an NFT itself. So take in an NFT resource. It's not going to return anything. And then a public function withdraw. And this is going to take in a withdraw ID, right? So the ID to withdraw, which is a UN64, and it's going to return an NFT resource back to the client. And we got Aiden with the smiley face in the chat. What's up, Aiden? My thumb is still burning. Okay, so now in this deposit function, so we take in this token, and this is an NFT resource. So this is actually the cool part about this is that we've actually learned how to do this already. So in previous chapters, we went over how do you deposit and withdraw from dictionaries, right? So we actually already know how to do this. So let's just do it again. Self.owned NFTs at token.id, and we can force move in the resource just like that. So super simple, right? We already learned how to do this the previous chapters, and I guess if you want to go back to that, where is it again? I think in maybe in chapter 3, day 3. No, chapter day 4. No, day 2. Yes, right here. So chapter 3, day 2 is what goes over this, right? Resources and arrays, and more specifically, resources and dictionaries is exactly where you're going to want to look to go over these concepts again. All right. So boom, now we want to withdraw. So how do we withdraw? Well, we can just say let NFT. So we're going to move out an NFT from the dictionary, self.owned NFTs dot remove at the withdraw ID, right? That's the index. And, then we're going to return NFT back to the client. Now, I think it's being buggy. I'm almost, oh no, it's because I think maybe I forgot to initialize owned NFTs. That could be why. Self.owned NFTs, empty dictionary. Why is it giving me, I'm pretty sure this is just bugged, so let me refresh the page. And it, yeah, okay, well, it was somewhat bugged. This maps to that. Oh, I forgot this. Oh, this is supposed to be key, not at. Key. And what else? Oh, yeah. And so this error is saying, mismatched types, expected hello world.nft got hello world.nft optional. So does anyone remember how to fix this problem? It's what's happening is it's saying this type is a optional, but we just want the actual NFT resource. So how do we unwrap this optional? Any guesses? There's actually two ways to do it. Nice, tab Cole. Yep, exactly. That's one way. We could do that. Sweet says you have to yell and interrogate it. We could also do that for sure. Sweet, start yelling. Yeah. Yep, so Tabco got one answer, and then the other answer is, at least the one that I prefer, is panic, because with panic, sweet with the angry face. Um, but with panic, you can actually give it like an error message. So, this is totally fine to do this one. But if you want to give an error, you can say like, hey, this NFT does not exist inside this collection. Because if this were to panic, that would mean that self.owned.nft.remove at this withdraw ID is null or nil. And if this is nil, then that means that there was no NFT in here with that ID. So we can say, hey, this NFT does not exist inside this collection, and then we can return the NFT. Now, there's one more error here that we haven't talked about yet, and we're going to talk about now. So it's saying missing destructor for resource field owned NFTs in type hello world.collection. Now, this is interesting. So what we haven't talked about yet is that every single resource, like remember way back in the day, we talked about how every single resource has a UUID in it, right? So without even defining it, every single resource on the blockchain has something called a UUID, and this is a unique identifier across the entire blockchain. So no resource will ever have the same UUID. And so, for example, if I tried to redefine it here, it would say, don't do that. It says, cannot declare field here UUID, and that's because it already exists. You just can't see it. The same thing is with this thing called the destroy function. So every single resource on the blockchain has something called a destroy function. You just can't see it there. But with a destroy function, you can actually redefine it by putting it here and then putting some behavior in here to do something if this resource gets destroyed. So for example, if we were to destroy a NFT resource, like for example, if we were to write like destroy NFT, before this resource actually fully gets destroyed, it would run this destroy function. Okay, so it's what gets run when the resource is actually completely destroyed. So we're not going to do anything here, but the reason I'm mentioning this is because when you have nested resources, which is when you have a resource inside of another resource, you have to define your own destroy function. You have to. It makes you. So in this case, because we have a resource dictionary here, or even if we just had a plain old resource, right, just like this, but because we have any sort of resource inside another resource, which is collection in this case, you have to define a destroy function that explicitly destroys self dot, the nested resource. So Cadence needs to be told that when collection is destroyed and this destroy function gets called, it wants you to tell it that you also just destroy self.owned NFTs. Otherwise you could do something in here like I don't know, like a loop through the NFTs and call some function, right? And call some function. But we're not going to do that. So we're just going to straight up destroy the NFTs so that if someone destroys this collection, it'll just destroy all the NFTs with it. All right. So with that being said, we can go ahead and redeploy this contract, and we have ourselves, a kind of an NFT contract. We still have a long way to go, but sort of an NFT contract. So we can go into our transaction, and instead of saving NFTs to our storage now, we can actually do hello world, let collection be hello world dot, create collection, and then move the collection into storage at /storage/my NFT collection. Perfect. Now, actually, one thing I forgot to mention is that every single workshop, I let all of you decide what our NFT is going to be called. So, like I said, the rest of this bootcamp, we're going to be coming up with our NFT contract. So it's up to all of you to figure out what we're going to call our NFTs. In the first, I don't know why that's popping up. In the first bootcamp, we called them Baby Jacobs, and I think in the second bootcamp, we called them Busy Bees. So all of you get to decide what do you want our NFT contract to be called. Our NFT is better. Yeah, you want to name it that? I like that. That fits the theme of the playground. So everyone, you have to all vote on. You can either thumbs up an idea, or you have to provide your own idea, and whichever one gets the most votes, that's what we're gonna name our NFT contract. R2E2 wants Atom. Young Jacob. Fire Dumbo. Uh-oh. All right, whichever one gets the most votes. Here, I'm gonna put a thumbs up on every single one. Whichever one gets the most votes. Oh, I accidentally hearted that one. So thumbs up what you want the contract to be named. All right, votes are coming in. Votes are coming in. Right now, Young Jacob is in the lead by Kelcoin. Oh my God, Kelcoin. Why are they always me? First it was Baby Jacob, now it's Young Jacob. So is the next one going to be like a teenage Jacob? Until I'm just dead? Is that what it's going to be? All right, so it looks like Kelcoin's won. Okay, so we're going to name our contract Young Jacob. All right, boom. That's the name. All right, so let's deploy Young Jacob. Great job, everyone, for participating. And let's go back to our transaction. This is now called Young Jacob. And we're going to deploy Young Jacob to storage and just say Young Jacob collection. Awesome. So let's log in here. We saved our collection to account storage. All right. So let's go ahead and run this from account 1. And it says we saved our collection to account storage. Woohoo! Yay, it's missing an E. I guess the playground stinks, but yay, it worked. Sweet. So now we have ourselves a collection. So let's call this transaction setup collection. Now, by the way, taking a quick break here, just for a second, let's think about like how this ties into the broader ecosystem. So I'm sure that a lot of you, before this bootcamp and during this bootcamp, have come, to some sort of experience where, you were interacting with a new NFT project, and they said, "Wait a minute, you have to set up your collection before we can give you NFTs." So as I'm sure you can see now, the reason you have to do that is because the project wants you to sign a transaction to save a collection to your storage so that they can give you NFTs. They can deposit NFTs to your collection. So I'm hoping that this, helps you understand not only, Cadence, but helps you understand why projects do that in the ecosystem. Why is it that you have to initialize collections before you can buy something or deposit something? It's exactly for this reason, because you save a collection in your storage and then you can interact with it. And it's the same thing why, when you're in the Blockdo app and Blockdo says, oh, you have to, initialize your wrapped flow token, or you have to initialize your go to goats collection or your float collection. This is the reason for that. It's because you need a collection in your storage to be able to receive NFTs or tokens, right? So I hope that helps. Anyway, so let's make another transaction, and this is going to called deposit NFT. All right, so let's copy some code, paste it in here. And what we're going to do now is we're going to get a collection. So get a collection, and the type for this is going to be a reference to a youngjacob.collection. So does anyone have any guesses? How are we going to get a reference to our collection? What's like the keyword in Cadence that's going to allow us to get a reference to our collection? Borrow. Great job, Willy Blue. So we're going to borrow our collection. Awesome job. Then we're going to deposit the NFT. Awesome. I'll just put it in here. Cool. So let's go ahead and borrow the collection. So signer.borrow. And we're going to say, you got it correct this time. You did. I know. Once you spend some time with me IRL, you just become such a genius. I know. It's crazy. So signer.borrow a reference to youngjacob.collection from /storage/ what do we call it? Young Jacob collection. All right. And we have to panic if it doesn't exist. So we're going to, panic. I'm going to do this on a new line just so we can see it and say, worst case, like this collection does not exist. All right. So we borrowed our collection. And now we're going to deposit the NFT. So collection.deposit, right? It's calling the deposit function, which is coming from right here. We implemented this. And it's going to say, we're going to deposit, we're going to move in a create or young Jacob dot create NFT. Oops, create NFT. Done. So it calls young Jacob dot create NFT, which is this function that creates the NFT, returns the NFT resource, and then passes that into the token, right, in the deposit function, which then goes to the deposit function and puts it inside owned NFTs, just like that. All right. So now we can log we deposited an NFT to our collection. So let's go ahead and run this from account 1. Let's send it. And it says we deposited an NFT to our collection. Now, what's going to happen? Any guesses if I run this from account 4 right now? Anyone have any ideas what's going to happen? Nice, Willie Blue. Willie Blue's on fire today. So, and great job, R2E2. Nice. So it breaks. And the reason it breaks, let's see what happens. We send it. It says this collection does not exist, which is exactly what we wrote right here. And that's because we never set up our collection. So we have to go ahead from account 4, set up our collection. Let me change that. Let's set up our collection, send it, go to deposit NFT, and now we can deposit an NFT, and it's totally fine. Woohoo, we did it. So now the issue is we want to figure out, well, how do we actually make sure the NFT is there, right? We want to be able to read from it and be like, okay, an NFT is there, it's all good. So what we can do is we can say public function get IDs, and this is going to be a function that returns an array of Uint64s, and it's going to be very simple. We're just going to say return self.ownedNFTs.keys. So it's going to return the keys of this dictionary, which is literally just an array of the keys. So it's going to return an array of Uint64s, and that way we can at least see the IDs of all the NFTs inside our collection. But now there's a problem. So I don't know why Steam is popping up, but now there's a problem. What's going to happen when in our script, right? We're going to name this script read NFT IDs. Are we going to be able to get are we going to be able to call the get IDs function inside read NFT IDs? No, we're not. Good job, R2E2. And the reason for that is because we never exposed our collection to the public. So we talked about this in the last workshop, but right now, because we're just saving this to account storage, there's no such thing. Let's go back to this chapter. There's no such thing as a public path right now. It doesn't exist. In fact, if we go to our day 3, there's no public path. And the only way to access the public path of or the only way to call something from account storage in a script is to read the public path, because in a script there's no signer, right? So we're allowing everyone to read from it, and so in order to allow people to do that, you have to put it to the public path. So what we can do is, and by the way, is everyone okay with that concept? Like, does everyone understand why that is? Because if you don't understand why that is, just let me know in the chat, because it's really important to understand that why we can't call get IDs in the script right now. So if you don't understand that, don't be afraid to ping me in chat, because that's a really important concept. But what we can do is we can say signer.link. We're going to link it to /public/young Jacob collection. And the target is /storage/young Jacob collection. So it's going to take the storage path and provide an arrow to the public path, just like we see right here. It's a capability, right? And the type is going to be a collection or a young Jacob collection, like that. Boom. So now let's go back to our contract and redeploy it. So it resets all the account storage state. Let's go ahead and redeploy. Redeployed. And now we can go and set up a collection from account 1. And boom, we saved our collection to account storage. And let's go ahead and try and read the ID. So right now, it should return an empty array, right? Because we have no NFTs inside our collection. So we want to end up returning a Uint64 array. So let's say let collection equals, and we're going to pass in the account address. So first, remember from the last workshop, we have to get the public account. by saying get account and the account we pass in, which is an address. So you get the public account dot get capability. So you get a capability. What's the path? Well, the path is /public/young Jacob collection, right? It's the public path. Put that in there. Then we have to borrow it. So dot borrow, and the type is a reference to young Jacob dot collection, right? This is the type that we linked inside our link right here. All right. We know it's there. And then if it doesn't exist, we can panic and say, this collection is not linked public. And then we can simply say collection.getIDs. Like that. Now it's giving us error because we forgot to import young Jacob from account 1. And we have to return collection.getIDs, right? Which will return an array of UN64s. So right now, if we put in account 1, let's send it, and what happened? Why does it not like that? Gotta love the playground. Gotta love the playground. Oh, because it was bugged, maybe? What? Ugh. I hate the playground. Bum bum ba-da-dum. I hate the playground. It's so annoying. Let's refresh again. Soon? Yeah. Thank God. All right, let's try it with account 2 maybe. So let's set up a collection with account 2. Let's go ahead and read NFT IDs. Account 2. It should say, okay, thank God. So it's an empty array, right? So nothing exists. But let's go ahead and deposit an NFT to account 2, right? So deposit NFT to account 2, send it. All right, we deposit an NFT. And now if we go back and read our NFT IDs from account 2 again, woohoo, we have an NFT right there. And the value is 2. So apparently the NFT's ID is 2. Pretty cool. So we have a NFT. And if we wanted to go again, deposit another one, there we go. Read NFT IDs, count 2, execute, and now there's 2. And so the next one apparently is 3. So a quick note that it's returning the IDs to the NFTs, which is coming from the UUID. So on the playground, because it's an emulator, the UUID is like a normal number, like 2 or 3. But on the actual blockchain, it's like 5, 7, 2, 3, 17, 21, 100. Right? It's like a huge number because obviously on the main blockchain, there's so many resources that they have to be bigger numbers. All right. So that is collection for you. Now, we've run into a problem, ladies and gents. And the problem, actually, I'll let you figure out the problem. What is the current problem with linking this to the public? Any guesses? Why is it bad that we linked this to the public? I think R2E2 is the answer. Here we go. We can delete the collection, kind of, but that's not the one I'm looking for. But that's kind of. Yes, exactly. Yes, exactly. So, well, by delete, what do you mean by delete? Like, there's a different word I'm looking for. Not delete, but what can someone do to the collection? Exactly, Boaz. Yes, exactly. So I think R2E2 meant the same thing. But the problem is that right now we have linked youngjacob.collection to the public. And this is a big problem because now anyone can run a transaction and publicly borrow youngjacob.collection from anyone's account. And because it's the youngjacob.collection type, they can withdraw. So this is a really big problem because right now anyone can run a transaction and withdraw from our collection. So what is the solution to this? And we talked about this two workshops ago. So private function, close, yes, exactly, Tabcola, that's what I'm looking for. So the answer, exactly, Amethyst. Nice, look at all of you learning. Wow, I'm so proud. So the answer is a resource interface. So public resource interface. I'm going to call it collection public because that's what it's always called. I don't know why. That's like a standard collection public. And so what we're going to do is we're going to expose only the things we want to be called publicly. So deposit, we don't care if people deposit to our collection, right? Like give me money. And the other one is going to be get IDs. We don't care if people get the IDs from our collection because why would we care, right? And it's really important to allow for this to be public because otherwise, apps like Blockdo or a website wouldn't be able to read the NFTs in our collection. So there we go. So public function get IDs. Cool. So of course we have to make sure that we implement this on the resource, and we're good to go. So we can redeploy this contract. We're good to go. And now when we set up the collection, when we link it to the public, we're going to also restrict it to youngjacob.collectionPublic. So now we're in a really good spot because only the public can, and also we have to fix our script now because this doesn't work anymore. We have to add the restriction, or else it's not even gonna borrow correctly. So now we have the restriction, and now the public can no longer withdraw from our collection. We did it. Great job, everyone. We conquered it. So I believe I know that seemed like a lot, but I believe that's only day 3, right? Is it? Well, we did collections. We did, oh, I'm sorry, that's not, wait, maybe? Did we do borrowing yet? Did withdraw, wait, is see if we're supposed to do borrowing yet. Okay, we didn't do that yet. Okay, cool. That's day 3 for you. So on to day 4, which is the last day of chapter 4. Wow, I'm getting emotional. We're almost done. But we're on the last day of chapter 4, and this is going to be transferring, minting, and borrowing. So let's go ahead and do that. So one issue right now is we can't actually read information about our NFTs. So inside our NFT, I'm going to add like a name field, like a string, and inside this name field, I'm going to call this, actually, I'm just going to put this right here, say self.name, name. And also, I had some people asking me why I put underscores in my init variables. It's just a habit. I don't know why I do it, to be honest. You don't have to. Like, you could easily just put this like this. And also, I want to also note that this is very different. This is very different from this. These are two very different things. Because this in Cadence, an underscore and a space, actually means that you don't have to put the argument label. So that's very different, but I like to put underscores just because I like to differentiate between the init variable and the variable that's above. Again, I don't know why I do that, just a habit. Okay, and then when we create the NFT, we have to make sure to pass in the name as well. So name string, and we say, name. Cool. And by the way, what I meant by that is like, so if you have underscore space like this, then what that means is down here, you don't even have to you don't put the argument label. You just put name like that, which is pretty interesting. But I don't like that. I like being very explicit about my variables. So yeah, okay. So now our NFTs have a name, but so the problem is that inside our collection, there's no way of like reading NFTs, right? So are the only way to read metadata, right, name about our NFT is to withdraw it, read information about it, and then deposit it again. But as we've learned, that's a really bad way to handle resources. And instead, we would much rather, I would ask all of you, but I know you're going to get it right. The much better way to do it is borrow. So you want to add a borrow function called borrow NFT that takes an NID and returns a reference to the NFT just like that. We can say return a reference to self.owned NFTs at the ID as a reference to NFT. Now, one interesting thing, again, that we've talked about is so very, very recently, they came out with an update called Secure Cadence. And Secure Cadence actually changed the way we do this pretty significantly, where they now introduced optional references. So what we can do is we can add, we have to add the optional here, but it says, wait, we're returning a NFT reference, not an NFT optional reference, to wrap this whole thing in parentheses and unwrap it. Or you could add a panic here, but whatever. I'm just gonna put that just okay. So now we have a borrow one, and we obviously want to put this in the public so that we allow people to read information about our NFTs. But careful note, if you had a function in here called like change name that only the owner could call, then this would be really bad, right? Because then anyone publicly get a reference and then call change name or whatever. But because it's just simple variables, then it's fine. So let's redeploy this. And apparently it doesn't like it. Thanks, Playground. You're the best. Just kidding, you're the worst. Thing here. Deploy. Right, nice. So now we can go ahead, set up our collection. Set up our collection. Deposit. Oh, we just passed in a name now. So let's make a name string. In here, why is it not popping up in the thing? Come on, Playground. Okay. We're going to call this Boaz, and we're going to create the NFT. Boom. We deposit the NFT to our collection, and we can confirm that by going to read NFT IDs, typing in account 1, and it should return a array with one ID in it. Now we're going to make another script called read Nft Metadata, and we're going to take some of the code from this one, paste it in here. It's actually pretty simple because now, we already have the code to borrow our collection publicly. All we want to do now is add an ID. That's a UN64. And instead of returning get IDs, we're going to return borrow NFT with the ID that's right here. And so now the return type is a reference to a young Jacob.nft. All right, so in order to know which ID to pass in here, we had to first get IDs, right? And we saw that, oh, wait, look, it might be small for all of you, but inside here, it has a ID with 1. So we know that we have to, in the script, we have to pass in 1. Now, of course, it's being buggy, but the account is 1 and the ID is 1. So if we execute, we should get a whole NFT right here. It's a young.jacob NFT, and the fields are, it has an ID with value 1, and it has a name with value Boaz. So perfect. We borrowed an NFT. Woohoo! Woohoo! Perfect NFT, I know, right? It's just such an amazing NFT with such an amazing name. So amazing. Woohoo! All right. So, one of the last things we're going to talk about are transferring and minting. So, what are some problems you all see with the way that minting is done right now? Is there a weird, like, what? I mean, maybe in some cases, but what's sort of an issue with this function right here? Like, imagine if this was go to goats. Would this be a problem? Yeah, it's a problem. Um, and it's a problem because anyone can create their own NFT. So obviously, we don't want that. That's not good, right? So let's go ahead and let's not do that. And we're going to make an init function for the contract like this. All right. So we make an init function. And so this is going to be an interesting concept that we haven't really talked about yet, but we're going to now. So this is going to be like pretty much a whole lesson on like admin capabilities. So what happens if you want someone to be an admin of a contract? How do you handle that? Well, let's do it. So this init function is the init function of the contract, right? So every contract has an init function. And what we're going to do is that inside of here, we're actually going to store what's called, or we're going to make an admin resource and store that admin resource to the account that is deploying this contract. All right. So let's right now create a resource called minter, be an admin, and we're going to take this function and put it inside the minter. So what we just did is we made it so that only someone with a minter resource can create NFTs, right? The public can't do this now. Only people with the minter resource, public resource minter, can create an NFT by calling this function. So how do you give people a minter, right? Because obviously we don't want to make a function called like public function create minter, right? That would stink because then anyone could just call this function and then start making NFTs. So what you do is in the init function of the contract, you say self.account.save. The value is create minter, and the path is going to be /storage/young Jacob minter. So this is interesting because so far we've only talked about account storage in transactions. right? Saving and linking and borrowing, right? But um, inside a contracts init function, you can access the auth account, right? The auth account, it's this type that allows you to change account storage. You can access the auth account of the account deploying the contract. So who is the auth account in this case? Which account of these 5 accounts? What is self that account referring to here? Yeah, 1. Exactly, Tabcole. Yeah, and good job, R2E2 as well. So we're going to save the minter to account 1, all right? And it's pretty simple, actually. It's just like this. Oh, oops. Mint. So let's go ahead and deploy the contract. And now we deployed it, and account 1 has the minter, all right? So what we can do is inside deposit NFT, we're no longer going to allow people to sign a transaction to just create their own NFT. So we're not going to allow that anymore. So you'll see now we're getting an error. We can't even call create NFT because it doesn't exist. So what we have to do is we have to first borrow the minter, and then the minter will deposit to a collection. So this transaction is now signed by, the minter now. Because the minter, only the minter, right, can borrow from its collection because it's not linked to the public, right? So only the minter can borrow this. But because depositing can be done publicly, the minter can just publicly deposit to a account. So first step is to borrow the minter. So let minter equals a reference to a young Jacob.minter equals signer.borrow, a reference to a young Jacob.minter from /storage/young Jacob minter. That's what we called it. And we're going to panic if it doesn't exist. Uh, this account not a minter, right? And then instead of borrowing our collection here, because this is no longer the person signing the transaction, we're going to say let collection equals a young Jacob collection that's restricted to young Jacob dot collection public equals, and then actually I'm going to get rid of this type because it's going to be a lot of code here, so we don't even really need to put the type. But we've already done this before in our script, so we actually know how to do this already. We can just take this code, get the public collection, right? And put that right here. Boom. Now we have the public collection from the different account, but it's getting it from account, right? So we have to add that as a address here, as a parameter, right? So we get the account, we get the public collection, then we can say collection.deposit, right? And then it's saying, instead of saying young Jacob.create NFT, we're going to say minter.create NFT. So we take the minter, and say minter.create NFT. So how is this for everyone? Is this sort of making sense? Right? This is now signed by the minter. And the minter will pass in what account it wants to give the NFT to and the name of that the NFT as well. So the minter wants to give this to account 2. So let's first, in some theoretical world, let's assume that account 2 had already set up their collection, right? So we're going to do that now. Then account 1 is going to say, okay, let's give it to account 2, and the name is going to be tabcol. Okay? So when we send this remember, it has to be account 1 because they're the one with the minter. Let's send it. And it says we deposited an NFT to our collection, or we should say their collection now. But if we go to read NFT metadata, or actually read NFT IDs, let's read it from account 2 because we just deposited to that person and happen. Huh? That doesn't make sense. Can I just restart, I guess? Put the contract, set up the collection for account 2. Okay. Deposit to account 2. The name is going to be tabcol from account 1. So the minter. Send. And then read NFT IDs from account 2. Okay, so I don't know. The playground was glitched, I guess. I have no idea. But anyway, yeah, there we go. So now we have the NFT inside of storage. Nice. So, yeah, like you can imagine in the real world, right? Goats probably has some minter, right? Some admin that has the resource, and yeah. Now, quick note that remember the init function is only ever run one time, right? Because in the real world, you only ever deploy a contract once. Of course, here we're messing around, so it's on the emulator and we can do it however many times. But in the real world, you only ever do it once. So what would happen is, probably the minter, right, or the admin of the goats collection would probably want to add another function here called public function create minter inside the minter itself, just like this, so that whoever gets this original minter can create new minters and give it to other people, right? So that's probably what you would want to do. But we're not going to talk too much about that because that's a more complicated topic. Okay. So bada bing, bada boom. That is a lot of stuff. And I guess the last topic is transferring, but that's not really a lot of new stuff to cover. You probably can already understand how you transfer an NFT, but let's just do it anyway. So let's just copy some code over. Now, this is going to be signed by the person sending the NFT, right? Because only the person, the auth account, can withdraw, but they can deposit to whoever. So the account, let's just call this like the recipient, and the ID of the NFT. So what's like the ID they want to transfer? So first, borrow the givers collection. So it's going to be a young Jacob.collection type. So it's signer.borrow a young Jacob.collection from /storage /young Jacob collection, right? This account does not have a collection. Then we're going to borrow the public collection of the recipient. So get account of the recipient, that get capability to their public collection, and then say, okay, withdraw. So withdraw the NFT, and then down here we're going to deposit the NFT. So should call this giver collection and call this one recipient collection. So we're going to withdraw it. So let NFT, we're going to move in giver collection dot withdraw. The ID is ID. And then we're going to say recipient collection dot deposit token. Token is just going to be the NFT that we move. All right. So I know I just moved through that quickly, but a lot of that is just a recap of what you pretty much already know. That we transferred NFT. Does transferred have 2 R's or 2 R's or 1 R? Transferred. 2 R's. Wait, yeah, okay, 2 R's. We transferred NFT. English. Woo! I know Cadence, but not English. Okay, so if we go to our read NFT IDs, let's just make sure that both are set up. So let's set up account 1, set up account 2. Actually, let's use different accounts. Let's use because we know 2 has one. So let's set up 3 maybe. Okay, cool. So we know that account 2 currently has 1 NFT, right? Has 1 NFT, and account 3 has none. All right, but we're going to change that. So we're gonna take the NFT with ID 2 from account 2. That's convenient, and move it to account 3. So let's go to transfer an NFT. The recipient's going to be account 3. The ID is 2, and we're assigning this from the giver, which is account 2. So let's send it. We transferred an NFT. Now if we go back to our read NFT IDs, if we go to account 2, we should have nothing. Right, so let's run that again. We have nothing, but account 3 has the NFT now. Nice, we transferred it. All right, it's dabbed at my computer. So yeah, how are we feeling? Are we feeling like absolute champions, like flexing at the computer? Are we feeling like freaking legends? Or are we feeling like confused and lost and dazed? Legend in training? You already are a legend, boss. But love that. Love the optimism. Lots to catch up on and review further. Yeah, that's totally fine. Yeah, like I said, this stuff is not easy. It's really not easy, but I have so much faith that that you can all do it after reviewing, and it'll be all right. Also, I noticed that Kelcoin added some Emerald Fire. I love that. I love the colors on that. It's great. Thanks for doing that, Kelcoin. Are you here? Oh yeah, you are here. Nice. Awesome. That's great. Kelcoin with the emojis. Oh, and the heart. That's sick. Oh, it's great. So yeah, everyone, I think oh, you made the amethyst? Thank you. Very kind. So yeah, everyone, I think that's it. That is okay, so that was part 2 of creating an NFT contract. Next week, we're gonna go over chapter 5. Day 1 and 2 are going over concepts we're gonna need for day 3, and day 3 is gonna be part 3 of the NFT contract. So yeah, we only have 1 week left, everyone. Um, kind of sad. Thanks so much for sticking around. I hope you're enjoying the boot camp so far. And if you are, me know. And thank our instructors, as always, for doing so much to help you along the way. And good luck. Good luck. Have a great weekend. I really mean that. Have a fantastic weekend. And I'll see you all next Wednesday for our next camp. So, and Amethyst, good luck on your 100 days of excellence. Do it. I hope this was a good start for today. All right, everyone. Peace out. That's it. And have a fantastic weekend. Love you all. Bye bye. Peace.